Most military conflicts have always been fought on land, but today they have shifted to the skies. Nowadays, small drones represent a significant threat, causing colossal damage and being difficult to shoot down. But before we begin, subscribe to our channel and leave your like. Now, let's get started. Theme 1, the new era of smart weapons, precision, efficiency, and control. The evolution of military technology in recent years has been marked by a drastic transition, the shift from human protagonism on the battlefield to the dominance of machines and artificial intelligence. This movement, once imagined only in science fiction scripts, is now materializing in equipment such as the Skynex air defense system, the armed Dogo robot, and the Coquille X ground vehicle. These innovations represent more than just technical advances, they signal a paradigmatic change in how armed conflicts are conducted and won. The Skynex, an air defense system developed in Germany, is an example of this new approach. With automatic guidance and stabilization, it can neutralize targets such as drones and cruise missiles at short distances with an impressive firing rate, up to 1,000 projectiles per minute. Its cost, just $4,000 per unit, represents a revolution in cost benefit compared to more traditional systems like the American Hawk, which costs about $50,000. Additionally, experimental versions equipped with 30 kilo lasers point to a future increasingly close to Star Wars. On the ground, the Dogo redefines the concept of close combat. Weighing only 10 kilos and armed with a Glock 9mm pistol, this mini-killer robot moves silently, climbs stairs, navigates narrow corridors, and identifies targets with high-resolution cameras. A simple tap on the screen allows the operator to authorize a shot. With night vision, audio communication, and even pepper spray, the Dogo is a concrete example of how robotics can reduce soldiers' exposure to dangerous situations. The Coquille X, the world's first ground interceptor, impresses with its speed, armament, and invisibility. Capable of reaching 200 km/h on roads and operating efficiently off-road, it remains hidden until the moment of action. Its combat helmet, equipped with artificial intelligence, provides the operator with a 360-degree panoramic view, automatic threat analysis, and assisted aiming. This system delivers an almost instant response, becoming a direct extension of human perception and lethality. The integration between human and machine in these systems is the most striking aspect. While the operator remains a fundamental part of the decision to shoot or advance, increasingly they act as a supervisor, an interface between machine and mission. Artificial intelligence and sensors replace continuous surveillance, distance calculation, and weapon targeting. Humans in this new scenario become strategists and analysts, no longer physical combatants in the traditional sense. However, this growing automation raises urgent ethical, legal, and philosophical questions. Who is responsible for a mistake made by an armed robot? To what extent can decision-making be delegated to a machine? These questions remain open and need to be answered before automation surpasses human control. Furthermore, access to this type of technology is still limited to a small number of countries. This creates strategic imbalances, especially in regions already affected by political instability or prolonged conflicts. The uncontrolled proliferation of smart weapons could paradoxically make the world more dangerous, not safer. Nonetheless, the tactical benefits are undeniable. Increased precision, reduced human risk, and faster response times are decisive advantages in modern combat scenarios. Systems like Skynex can efficiently face swarms of drones, something unthinkable for conventional troops or traditional artillery. This changes the logic of war, which previously required numbers and now increasingly depends on algorithms and sensors. The new era of smart weapons is no longer a theoretical exercise, it's a reality. Lethal robots, automated air defense, and autonomous vehicles are already part of current conflicts, shaping 21st century warfare. The question now is not if machines will dominate battlefields, but how humans will maintain control amid so much mechanical autonomy. The balance between technological innovation and ethical responsibility will be the true battlefield in the coming years. Theme 2, invisibility on the battlefield, fiction or reality. Invisibility, a concept traditionally associated with science fiction stories, is becoming a tangible reality in the military field thanks to impressive technological advances. Today, adaptive camouflage materials and systems are changing how soldiers, vehicles, and even buildings can disappear from enemy sight, not only from the human eye, but also from thermal sensors and infrared and ultraviolet spectrum detectors. Among these innovations is quantum stealth, a material developed by Guy Kramer, which promises to transform stealth warfare as we know it. Quantum stealth is an ultra-thin coating, lighter than paper and cheaper than conventional camouflage uniforms, which reduces shadows by up to 90%. This drastic shadow reduction means the coated object barely casts visible contours, making it practically invisible. The material not only blocks direct vision, but also interferes with detection by sensors operating in different spectrums, including those seeing beyond visible light, such as infrared. This characteristic is especially useful for stealth operations where surprise and invisibility can mean the difference between life and death. Besides quantum stealth, the Swedish adaptive camouflage system takes invisibility to a new level. This system consists of hexagonal modules individually controlled to change color and pattern, allowing tanks and other vehicles to blend into their surroundings. They can fool thermal and optical sensors, making a tank look like a car, a bush, or even a rock. This dynamic mimicry is a direct response to the increasing sophistication of enemy detection systems. The practical application of this technology goes beyond traditional battlefields. Imagine a helicopter flying while appearing as a cloud, or a military building becoming invisible to eyes and sensors. These possibilities represent a qualitative leap for reconnaissance, infiltration, and even static defense operations. The ability to disappear from the enemy's visual and sensory field offers unprecedented tactical advantage. However, the advancement of invisibility technology raises questions beyond the technical. How can these resources be prevented from falling into the wrong hands? The proliferation of invisibility tech to terrorist groups or authoritarian regimes could destabilize already fragile geopolitical scenarios. Also, invisibility complicates conflict control since it makes identifying hostile combatants and vehicles more difficult, increasing the risk of accidental attacks or uncontrolled escalation of violence. Another challenge is developing countermeasures. As invisibility technologies advance, detection systems also evolve, seeking ways to identify hidden objects. This leads to a technological arms race that could make the battlefield even more unpredictable and deadly. In any case, the potential of invisibility in the military field is immense. Special operations, reconnaissance missions, and stealth attacks gain in effectiveness and safety with this technology. The possibility of acting undetected reduces risks to troops and increases chances of success. In summary, invisibility on the battlefield ceases to be a fictional concept and becomes a real and decisive tool in modern warfare. Quantum stealth and Swedish adaptive camouflage are just examples of what is already in development or advanced testing, signaling that the coming decades may see radical transformations in how wars are fought, with invisibility taking a central role. Theme 3: War Robots. Between logistical support and autonomous lethality, the increasing presence of robots on the battlefield has transformed not only how wars are fought, but also the very nature of conflict. From cargo transport to lethal attacks, these machines are becoming indispensable companions to troops, reducing human risks and increasing the effectiveness of military operations. Equipment like the Mission Master AUGV and the Dogo perfectly illustrate this technological revolution, mixing autonomy, artificial intelligence, and firepower. The Mission Master AUGV is a multifunctional robotic vehicle capable of performing a variety of tasks that previously required direct human presence. It transports heavy loads up to 1,000 kilos, performs reconnaissance in dangerous areas, and can even conduct medical evacuations, protecting soldiers by taking on the riskiest roles. This multifaceted capability makes it a fundamental element in modern operations, where speed and safety are essential for success. Beyond logistics, the Mission Master SP, an armed version of this vehicle, brings an offensive dimension to the concept of military robotics. Equipped with machine guns and rocket launchers firing up to 14 missiles of 70mm with a range of up to 7 kilometers, it can carry out precise attacks with minimal collateral damage. This combination of mobility, long-range firepower, and reduced risk to human soldiers marks a significant advance in combat tactics. On a more compact level and closer to direct combat, we have the Dogo, a mini-killer robot weighing only 10 kilos, armed with a Glock 9mm pistol and equipped with 360-degree day and night vision through 8-color cameras. The Dogo can navigate complex environments such as buildings and stairs without alerting enemies. With two-way communication and non-lethal options like pepper spray, it represents a versatile tool for urban and high-complexity missions. The efficiency of these robots lies not only in their technical capacity, but also in the change they promote in battlefield dynamics. dynamics. By delegating dangerous functions to machines, military forces can significantly reduce human casualties while maintaining an aggressive and efficient posture against adversaries. The strategic use of these platforms can determine the success or failure of critical missions. However, the use of armed robots raises important ethical and legal debates. Delegating the decision to kill to machines, even if supervised by humans, is a delicate issue. The consequences of technical failures, target misidentification, and risks of misuse or hacking represent challenges that still need to be fully resolved. International organizations are discussing regulations to ensure these technologies are employed responsibly. Moreover, integrating robots on the battlefield demands advanced technological infrastructure, including secure communication, reliable AI, and the ability to adapt to complex and unpredictable environments. This requires high investments and specialized training, which may limit the widespread adoption of these technologies by countries with more restricted resources. Despite these limitations, the trend is clear. Robots will be increasingly present not only as support tools, but as decisive combat elements. The continuous evolution of artificial intelligence and sensor systems promises to make these vehicles increasingly autonomous and effective, broadening the scope of military operations. In short, robots like the Mission Master and Dogo represent a future where the battlefield is shared between humans and machines, combining forces to maximize efficiency and minimize risks. The transformation of warfare through robotics is inevitable and underway, promising to profoundly change how conflicts are conducted in the coming decades. Theme 4: Mind Defense, the technology that saves lives and revolutionizes the battlefield. Modern warfare is not only about tanks and missiles. One of the most treacherous and silent threats on the battlefield is landmines. Their devastating impact has caused countless losses and operational limitations, forcing armies to invest in innovative technologies for detection, neutralization, and protection. In this scenario, systems like the Bobat-K, the M1150 ABV tank, and PPE-100 anti-mine boots represent crucial advances to save lives and ensure troop mobility. The Bobat-K, developed in Poland, is an automated mine-laying system capable of creating large minefields in record time. Able to carry 600 projectiles of various types, this compact vehicle, operated by only 2 personnel, can establish a defensive zone up to 1,800 meters long and 90 meters wide in just 22 minutes. Moreover, its reload is quick, taking less than half an hour, allowing agile and continuous operations. This rapid mine deployment capability is strategic to contain enemy advances and protect vital positions. Complementing the Bobat-K is the M139 Volcano helicopter, which drops 960 mines in a single flight, creating a highly effective and hard-to-clear aerial barrier. This combination of ground and air allows unprecedented flexibility and coverage in territorial control and defense against invasions. On the other hand, the safety of troops who need to cross these minefields is ensured by specialized clearance vehicles, such as the M1150 ABV tank. Weighing 72 tons, it is equipped with an anti-mine plow and line charges that launch rockets up to 150 meters to safely detonate mines at a distance. After this controlled detonation, the 4.6 meter plow clears debris, opening the way for troops and vehicles. With an approximate cost of $16 million per unit, this tank represents a high investment but saves countless lives in conflict zones. Besides heavy vehicles, individual soldier protection has also evolved significantly. The PPE-100 anti-mine boots from the United Kingdom withstand explosions up to 75 grams of TNT, protecting feet and legs from severe injuries. In Ukraine, spider boots, based on the Canadian model, support up to 100 grams of explosives. These technologies are essential for regions still bearing the legacy of mines left by past wars, affecting more than 50 countries worldwide. The threat of landmines goes beyond active conflicts, representing a global humanitarian and security challenge. They remain active long after wars end, causing civilian casualties and limiting the economic development of entire areas. Therefore, advances in technologies for mine deployment and deactivation are fundamental not only for military success, but also for post-conflict reconstruction and peace. Innovation in these systems continues. New detection methods, such as advanced sensors, specialized drones, and artificial intelligence are being integrated to accelerate mine identification and removal, minimizing risks for human deminers. In summary, mine defense is an area where technology literally saves lives. From rapid and efficient deployment of minefields for strategic protection to clearance and individual protection, each advance makes a huge difference for troops on the ground. Investing in these technologies is investing in safety, efficiency, and, above all, preserving life in an environment where danger may lurk work at every step. Theme 5, Active Defense Systems and Armor, the new era of military protection. The evolution of defense systems in military vehicles is a direct response to the increasing lethality of modern weaponry. As threats become more sophisticated, protection technologies also advance to ensure troop survival and machine integrity on the battlefield. Two emblematic examples of this revolution are the Trophy system and Swedish adaptive camouflage, which elevate the concept of armor to a new level. Trophy is the only active protection system proven in real combat. Developed for tanks, it works by detecting and neutralizing threats such as RPG rockets, anti-tank missiles, and shaped charge projectiles before they hit the vehicle. By intercepting these threats, Trophy saves lives and preserves valuable equipment, but generates fragments that can be dangerous to nearby troops. This trade-off requires tactical care in its use to avoid collateral damage. Unlike traditional systems that rely solely on passive armor resistance, Trophy adds an active defense layer capable of reacting in fractions of a second to imminent attacks. This represents a huge advance in the safety of armored forces, especially in urban combat and guerrilla warfare, where quick surprise attacks are common. Complementing this active defense, the Swedish adaptive camouflage system allows tanks to disappear visually in the environment. Using individually controlled hexagonal modules, the vehicle can assume various appearances, from ordinary cars to bushes and rocks. This mimicking ability not only confuses optical sensors, but also hinders thermal detection, disorienting the enemy and increasing survival chances. The combined use of these technologies not only protects vehicles and occupants, but also redefines military strategies. Adaptive camouflage allows infiltration and strategic positioning without being detected, while Trophy provides a last line of defense against sudden attacks. Besides these cutting-edge systems, other innovations in armor involve composite materials, ceramics, and coatings that absorb or deflect energy from explosions and impacts. These technologies work together with active defenses to create an almost impenetrable protection field. However, the arms and defense race continues. As defensive technologies evolve, new threats arise, such as missiles with multiple warheads and kamikaze drones, requiring constant updates and heavy investments. Another important point is the impact of these technologies on vehicle weight and mobility. Heavy armor increases protection but may reduce speed and agility. Active defense systems and adaptive camouflage attempt to balance this equation, offering protection without sacrificing performance. Finally, the incorporation of these technologies also impacts logistics and troop training. Operators need to be trained to use complex systems, while armed forces must invest in specialized maintenance to ensure equipment's continuous effectiveness. In summary, active defense systems like Trophy and Swedish adaptive camouflage symbolize the new era of military protection. They offer a combination of advanced technology that transforms tanks and armored vehicles into almost invisible and nearly immune machines to direct attacks, redefining strategic and tactical possibilities on the modern battlefield. Theme 6, Innovation in Barriers and Structural Protection, Modular Blocks and Rapid Solutions on the Battlefield. In combat environments, protecting strategic areas is a constant challenge. Traditionally, sandbags have been used to erect barriers against explosions, bullets, and shrapnel, but their installation is time-consuming, requiring much labor and heavy equipment. To overcome these limitations, the company Wesco developed foldable modular blocks, revolutionizing the construction of protective barriers by making it fast, efficient, and versatile. These blocks are made of steel with aluminum coating, ensuring resistance to explosions, weather, and wear. Modularity allows them to be transported and handled easily, and they can be quickly assembled by small teams. To build a 10-meter wall, for example, only 2 people, a loader, and 20 minutes of work are needed, a significantly shorter time than traditional methods. The possibility of rearranging these blocks like pages of a notebook offers unprecedented flexibility. They can be disassembled, moved, and reused in different configurations, adapting to various battlefield needs. This feature is essential in dynamic scenarios where protection must be assembled, expanded, or reduced quickly according to troop movement and threats. Besides offering ballistic and blast protection, Wesco blocks also contribute to area containment, access blocking, and delimiting safe perimeters. Their robustness makes them reliable barriers against direct and indirect attacks, also protecting sensitive structures and equipment. Another important benefit is the reduction in weight and volume compared to sandbags, facilitating transport to remote or hard-to-access locations. zones. This mobility increases operation reach, enabling rapid protection of vulnerable points without heavy logistical resources. The application of these modular blocks is not limited to the military context. In disaster response operations, urban riot control, and critical facility protection, this technology offers a practical and effective solution. Its quick assembly and disassembly allow adaptation to emergency needs, optimizing time and resources. The development of this technology reflects the growing demand for solutions that combine efficiency, safety, and agility. On the modern battlefield, where reaction speed can determine mission success or failure, equipment that saves time and labor is a strategic differential. Besides practical aspects, cost benefit is another relevant factor. Although the initial investment may be higher than sandbags, reusability and durability compensate, making Wesco blocks economically advantageous in the medium and long term. Finally, the adoption of these modular blocks demonstrates how innovation can transform seemingly simple aspects of military logistics, elevating them to technological solutions that directly impact troop safety and operational performance. In short, foldable modular block technology represents a significant advance in battlefield structural protection, offering speed, versatility, and efficiency essential for current and future challenges. Theme 7, Advanced Tactical Vision Technology, the Camaro Xaver SA, and the revolution in urban combat. In military and urban rescue operations, visibility is one of the greatest challenges faced by teams on the ground. Walls, obstacles, and confined environments limit the ability to identify threats, victims, or strategic points, risking the lives of soldiers, police, and civilians. To overcome this limitation, the Camaro Xaver SA was developed, a tactical vision system with the capability to see through walls, revolutionizing how armed forces and security teams operate in hostile environments. The Camaro Xaver SA uses millimeter wave radar technology to detect movements behind solid barriers at more than 100 meters distance. This real-time vision capability allows precise monitoring of who is moving inside a building, their exact position, and even the type of activity being performed, even in environments completely blind to conventional vision. This system saves lives in urban combat, hostage rescue, and police interventions, providing tactical advantage and safety to teams. Early threat recognition allows efficient planning, reducing surprises and ambushes that have historically caused significant casualties. Besides detection, the Xaver SA is portable and can be operated by a single soldier, being integrated into communication systems to transmit images and data in real time to commanders and remote teams. This connectivity enhances coordination among forces and improves decision-making on the ground. The Xaver SA technology is the result of years of research and development, combining radar, signal processing, and artificial intelligence knowledge. Its use is not limited to military operations. It is also applied in search and rescue missions, bomb disposal, and security at large events where threat anticipation is crucial. Another system highlight is its ability to identify not only the presence of people, but also their movements and postures, helping to distinguish civilians, suspects, or armed enemies. This minimizes mistakes and collateral damage, a vital aspect in densely populated urban areas. With Camaro Xaver SA, urban combat ceases to be a highly unpredictable environment and becomes a scenario where information is a strategic resource. This transforms the tactical approach, allowing teams to plan attacks, rescues, and evacuations with greater safety and efficiency. Although the system represents a remarkable advance, challenges remain, such as the need for specialized training, adaptation of traditional tactics, and protection of transmitted data against enemy interception. Finally, the Camaro Xaver SA symbolizes the convergence of high technology and real battlefield needs, showing how innovation can save lives and redefine strategies in environments where the invisible can be revealed, forever changing the dynamics of combat and urban security. Theme 8, Raider X Helicopter, the fusion of aerospace technology with racing car speed. In the modern era of armed conflicts, speed, precision, and adaptability are essential to ensure superiority on the battlefield. The Raider X helicopter exemplifies this evolution by combining the best of aerospace technology with features borrowed from racing cars, creating an agile, efficient aircraft capable of operating under extreme conditions. One of Raider X's main qualities is its ability to accelerate up to 200 knots, roughly 370 km/h, enabling rapid deployment to operational theaters. This speed does not compromise flight stability, as the helicopter is designed to fly slowly with great control, essential for reconnaissance missions, troop insertion, and close air support. The fully digital cockpit represents a revolution in human-machine interface. With advanced automatic diagnostic systems, the Raider X can identify and report faults in real time, reducing maintenance time and increasing operational availability. This feature allows technical teams to act preventively, avoiding critical failures during missions. Another highlight is the MOSA system, Modular Open Systems Architecture, which gives the helicopter the flexibility to quickly adapt its armaments and equipment according to mission needs. This modularity means Raider X can be configured for attack, transport, reconnaissance, or logistical support, optimizing resources and increasing versatility. Its aerodynamic design, inspired by racing cars, contributes to agility, allowing quick and precise maneuvers crucial to avoid threats and conduct operations in urban environments or difficult terrain. The combination of power and control provides a decisive advantage in dynamic combat, where survival depends on rapid response capability. Beyond technical capabilities, Raider X incorporates advanced communication and navigation systems, ensuring interoperability with other units and platforms. This facilitates tactical coordination and integration into modern combat networks, enhancing operational efficiency and joint reaction capacity. Fuel consumption reduction, resulting from efficient propulsion technologies, extends range and flight time, enabling longer missions without constant refueling. This is especially relevant in remote or long-duration operations where autonomy is crucial. Despite innovations, Raider X faces challenges such as high development and maintenance costs and the need for specialized training for pilots and technical crews. However, its strategic and tactical benefits outweigh these obstacles, consolidating the helicopter as an indispensable tool for future armed forces. In summary, Raider X represents the convergence of speed, advanced technology, and versatility, symbolizing the next generation of military helicopters capable of operating efficiently and safely in increasingly complex and demanding scenarios. Theme 9: K9 Vision, technology that enhances military dogs' capabilities. Military dogs have always been indispensable partners in combat, search, and rescue operations. Their agility, keen sense of smell, and threat detection ability are irreplaceable. However, technological advancement has brought an innovation that further amplifies these capabilities. K9 Vision, a high-quality video and audio system developed especially for military dogs, revolutionizing how these animals interact with their handlers in the field. K9 Vision consists of a lightweight, compact camera attached to the dog's gear, transmitting real-time HD images up to 800 meters away without noticeable delay. This transmission allows the handler to see exactly what the dog sees, even in areas of difficult access or reduced visibility, such as tunnels, closed buildings, or rough terrain. Besides video, the system offers two-way audio, enabling communication between the dog and the operator. Commands can be given remotely, even when the animal is out of direct sight, increasing control and efficiency during tactical operations. This communication also helps reduce risks for the dogs, as the handler can warn of dangers or direct the animal to safe zones. A distinguishing feature of K9 Vision is its ergonomic design that does not interfere with the dog's performance or comfort. The system is impact resistant, waterproof, and durable under extreme battlefield conditions, ensuring continuous operation. K9 Vision's application extends to various missions: explosive and narcotics detection, search and rescue in disasters, patrolling, reconnaissance, and urban combat. In each, the system significantly enhances the dog's operational capacity, allowing it to explore dangerous areas without directly risking the handler. Beyond operational benefits, K9 Vision reinforces the animal's safety. By enabling remote viewing and constant communication, it helps prevent accidents, ambushes, and other situations that could injure or kill the dog. This marks a significant advance in protecting these vital allies. The development of K9 Vision is a clear example of how technology can be adapted to improve human-animal interaction, increasing mission effectiveness without compromising canine welfare. Ultimately, K9 Vision shows that the future of security and combat relies not only on machines or weapons, but on the synergy between technology, humans, and their animal partners, working together to face increasingly complex challenges in adverse scenarios. Theme 10. Personal protection on the battlefield. The evolution of anti-mine boots and safety equipment. In today's armed conflicts, individual soldier protection is as crucial as the technology used in vehicles and weaponry. Among the most persistent dangers are landmines, responsible for severe injuries and deaths, as well as restricting troop movement and delaying military operations. To minimize these risks, the evolution of anti-mine boots and personal protective equipment has become a priority, with technological advances that have saved countless lives in war zones worldwide. The PPE 100 anti-mine boots, developed in the United Kingdom, exemplify this evolution. Designed to withstand explosions of up to 75 grams of TNT, they combine advanced ballistic materials with an ergonomic design that ensures comfort and mobility. Besides reinforced soles, these boots come with ballistic gaiters protecting the legs against shrapnel and fragments, significantly extending the soldier's defense area. In Ukraine, a country with vast mined areas and ongoing conflicts, spider boots based on Canadian models provide even greater resistance, supporting explosives of up to 100 grams of TNT. This additional protection is vital in environments where improvised mines and homemade explosive devices are common, increasing soldier safety during patrols and demining operations. Beyond boots, personal protection includes ballistic vests, reinforced helmets, and integrated detection and alert systems, forming a set aimed at ensuring combatant survival in extreme situations. Investment in protective technologies reflects growing awareness of the importance of preserving human life, especially in operations involving unpredictable risks and high danger levels. The effectiveness of anti-mine boots goes beyond impact resistance. They must also provide mobility and comfort so soldiers maintain operational efficiency. Lightweight materials, breathability, and ergonomics are fundamental factors in developing this equipment, ensuring protection does not compromise battlefield performance. Another important aspect is the standardization and distribution of these technologies among armed forces worldwide, often limited by budgetary or logistical issues. International partnerships and aid programs have facilitated access to this equipment, expanding protection for soldiers operating in conflict and mine zones. Besides military use, anti-mine boots and related equipment apply in humanitarian missions, civilian demining, and peacekeeping operations, where worker safety is equally critical. Continued development of these devices contributes to a future where landmine impacts are minimized, protecting both combatants and civilians. In summary, the evolution of anti-mine boots and personal protection represents an essential advancement in soldier safety, reflecting a global commitment to preserving life amid the violence of modern conflicts. This technology, combined with other innovations, forms a defense network that safeguards the individual, strengthens armed forces, and enables safer, more effective operations. Thank you very much for watching the video. If you enjoyed our content, please subscribe to our channel and leave your like. Also, check out other interesting content that is appearing on your screen right now, and I'll see you in the next video. See you next time.